So now I started recording. So I'm just gonna erase everything, uh, clear all my drawings. So now let's get started. So what we know, what we need for 3.4 is that they tell you that a wave a radiation has a wavelength of 600 times 10 to the exponent negative 10 meters, and they want you to find the type of radiation through calculations. So we have to look at the table and see what we have. According to this table, we're going to identify the type of radiation by using its frequency. So that means we need to find the frequency of the radiation with this particular wavelength. So from transverse waves, you know that the speed of a wave is equal to the wavelength multiplied by its frequency. And when it comes to longitudinal waves and electromagnetic radiation, to be specific, they travel at the speed of light, or the speed of light in a vacuum. And this speed of light has a specific symbol, which is c. So instead of writing v, we already have our speed, which is the speed of light, which is going to be denoted as c. So your equation goes from the speed is equal to wavelength multiplied by the frequency to the speed of light is equal to wavelength multiplied by the frequency. We only use the speed of light in a case where we have electromagnetic radiation. So we're going to end up dividing both sides by the wavelength so that we are able to calculate the frequency. So the frequency is going to be equal to the speed of light divided by the wavelength, which is going to be equal to, now the speed of light is a constant, which is 3 times 10 to the exponent 8 meters per second. So this is going to be placed here in place of C, and this is going to be placed here for the wavelength. And then we're going to end up with 3 times 10 to the exponent 8 and 600 times 10 to the exponent negative 10. We're going to end up with 5 times 10 to the exponent 15. And this is going to be in hertz. But this is not our final answer. Where 5 times 10 to the exponent 15 hertz, but it's still not going to be our final answer. Now we have to identify the radiation with a frequency that this falls into. So what do you think it's going to be, this radiation, or which radiation has this frequency? Just from the looks of the table, just from looking at the table, let me just do this. Zoom into that. Can you see it better now?
Is it radio waves?
Sorry, let me just erase. Now you can just focus on the exponents because this is actually the part where you have to focus on the exponents. Radio waves have a range of time, whatever number times 10 to the exponent 5 to whatever number times 10 to the exponent 14. Or actually, this is just 1 times 10 to the exponent 10. And then microwaves have take from 1 times 10 to the exponent 10 to 1 times 10 to the exponent 11. Those are your microwaves. And infrared waves have a frequency of whatever times 10 to the exponent 11 to whatever times 10 to the exponent 14. Ultra visible light, whatever times 10 to the exponent 14 to times 10 to the exponent 15. Ultraviolet, it starts at times 10 to the exponent 15 to 10 to the exponent 16. Radio X-rays, 10 to the exponent 16 till 10 to the exponent 18. Gamma rays, 10 exponent 18 to 10 exponent 21. So which one do you think it falls under? Because this has 10 to the exponent 15.
Is it radio waves?
Okay. Um, I thought maybe you get the gist of it, but it's gonna be invisible light. This is 15 and this is 15. So do you understand why I'm saying it falls into visible light?
Yes.
Okay. So yeah. But either way, I think we can move on. And they say state one application of the type of radiation identified in 8.4.1. So if you look at if you look in life, why do you think or where are ultraviolet light applied? Or what are the uses of UV light in real life?
I really don't know. I'm confused.
Okay. So it can actually be used in like dental practices. Usually it's used in medicine. Uh, yeah, it's usually used in medicine. I'm pretty sure you know where X-rays are used, right?
Yes.
Yeah, because it's literally called an X-ray. So it's usually used in medicine. Microwaves are used in your microwave. Radio waves are used by radios and your phone as well, if I remember well. Infrared rays. Have you seen do you have a TV remote next to you?
No.
Uh, so you can actually see infrared rays. Um, what you have to do is that you take a TV remote controller. It has this light. It has like this small bulb in front of it, right? And you open up your camera and you just press any button on that remote on that remote. Your camera is able to detect infrared rays. You'll see a bit of light. So if you want to see like if you want to see if you want to see if you want to see infrared rays, you can just do that. And then for visible light, for visible light, it's every color that we see. So literally just any color that you see is visible light. And ultraviolet, I think they also use it to scan for like babies. Like you see when a woman is pregnant and she goes to the hospital, and in order to scan for the unborn child, I think they also use it. And there's also X-rays, which is well, X-rays, we use it to scan our bones. And gamma rays, uh, I don't know any application of gamma rays as of yet, because they're actually very dangerous to the human body. So I'm not sure about gamma rays. But anyway, those like you need to know these applications because you will obviously get them in a test. So yeah. Anyway, I think we can move on to the next one. I'm just I'm just try to open up a question paper. Yeah. But anyway, from your side, do you have any questions regarding what we just did?
No, but I don't understand that well, the calculations yet, but I understand what you're saying, but I think I just need more practice on it.
Okay, so what I can say is that those questions, um they are they're mostly straightforward, but since you say you don't understand like that much of them, let me just look for another question paper, because the website that I used to access question paper, it's off right now. I don't understand why. But let me just check for more question papers. So anyway, since the meeting is also running out of time, can we just restart it while we're still waiting?
Yes, also are we having a double lesson?
If you're free, that's actually what I said. So
Yes, yes, I am.
okay, cool.
Okay, bye.
Bye. And